Integrate the function x into sin x. We can write integral x into sin x dx. Here there are two functions, x and algebraic function and sin x function. As per the rule isolate, a is for algebraic function and t is the trigonometric function. So algebraic function first comes. So let us consider this is the first function and sin x is the trigonometric function which comes later. So we can write second function. So integration we know f into g is equal to f into integration of g minus integral of differentiation of f into integral of g. So here f can be taken as the first function. So let f of x is equal to sin x, sorry x, and g of x is equal to sin x. So we can write integral x into sin x dx is equal to f into integral, that is x into integration of sin x dx minus integral of d by dx of the first function, that is x into integral of g of x, that is sin x dx, the whole dx. So which is equal to x into integration of sin x is minus cos x minus integral of differentiation of x is 1 into integral of sin x is minus cos x dx. So minus x cos x. So negative of negative plus integral of cos x dx, which is equal to minus x cos x. Integration of cos x is sin x plus c. So we can write minus x cos x plus sin x plus c is the answer. Integrate the function x into sin 3x. We can write integral x into sin 3x dx. So here are two functions, one algebraic function x and trigonometric function second one. As per the rule of isolate, algebraic function is the first function and trigonometric comes later, that is second function. So, and we know that integral of f into g is equal to f integral of g minus integration of differentiation of f into integration of g. So where f is the first function and g is the second function. So let us consider f is a x, or f of x is equal to x and g of x is equal to sin 3x. So we can write the integral of x into sin 3x dx is equal to x into integral of g of x, that is sin 3x dx minus integration of differentiation of x into integral of sin 3x the whole dx, sin 3x dx whole dx. So which is equal to x into integration of sin 3x is cos 3x upon coefficient of x is 3, so it should be divided, minus integral of differentiation of x is 1 into integration of sin is cos 3x upon the coefficient of x is 3 dx, which is equal to x upon 3 cos 3x minus 1 upon 3 into integration of cos is, sorry, integration of sin is minus, so let us write here minus cos, and integration of cos is sin x, so we can write sin 3x divided by coefficient of x is 3 plus c, or we can give the answer minus x upon 3 cos 3x minus 1 upon 9 sin 3x plus c is the answer. And let me write integration of sin ax plus b is equal to minus cos of ax plus b minus cos of ax plus b upon the coefficient of x is a plus c, and integral of cos of ax plus b dx is equal to sine of ax plus b upon the coefficient of x is a plus c. Okay. Integrate the function x square into e power x. So we can write x square into e power x dx. So here two functions, x square algebraic function and e power x is an exponential function. According to the rule of highlight, so algebraic function comes first and exponential function comes later. So let us consider first function f of x is equal to x square and the second function g of x is equal to e power x. And we know that integral of f of x into g of x, that is fg, is equal to f into integration of g minus integral of derivative of the function f dash into integration of g. So here we can write integral of x square into e power x dx is equal to f of x function is x square into integration of e power x dx minus integral of d by dx of x square into integral of e power x dx whole dx. So we can write x square into e power x minus integral of differentiation of x square is 2x into integration of e power x is e power x dx. So x square into e power x minus 2 times of, and again we can use the x into e power x is the product rule, where x is algebraic function and e power x is a trigonometric function. So algebraic function and trigonometric function. So let us consider the first function is x. So we can write integral of x into e power x dx, which can be taken as x square into e power x minus 2 times of x into integral of e power x dx minus integration of differentiation of x is 1 into integral of e power x dx, the whole dx, which is equal to x square into e power x minus 2 times of x into integration of e power x is e power x, and again minus of minus plus here 2 times of integration of e power x is e power x, and again integration of e power x, that is x square e power x minus 2x e power x plus 2 times of e power x plus constant c, or you can take e power x common, x square minus 2x plus 2 times of plus c is the answer. Integrate the function x into log x. We can write integral x into log x dx. So here x is an algebraic function and log x is a logarithmic function, and according to the rule highlight, logarithmic function is the first function and algebraic function is the later one. So let us consider log x is the first function and x is the second function, and we know that integral f of x into g of x, where f is the first function and g is the second function, f into integral of g minus integral of f dash into integral of g. So here we can consider f of x is equal to log x and g of x is equal to x. So we can write x into log x dx is equal to x log x into integration of x dx minus integral of differentiation of log x into integral of x dx, the whole dx, which is equal to log x into integration of x is x square by 2 minus integral of differentiation of log x is 1 upon x into integration of x is x square by 2 dx and whole dx, which is equal to log x square upon 2 into log x minus integration of or 1 upon 2 times of x dx, which is equal to x square upon 2 log x minus 1 upon 2 into integration of x is x square by 2 plus c. So we can write here x square upon 2 log x minus 1 upon 4 x square plus c is the answer. Integrate the function x into log of 2x. So we can write integral x into log 2x dx. So here two functions, x is an algebraic function and logarithmic function we have, and according to the rule of Eilert, so L comes first and algebraic function comes second. So we can consider here the first function is logarithmic function and second function is an algebraic function, and we know that integral f into g first function into second function is equal to f into integral of g minus integral of f dash into integral of g. So we can write here integration of x into log 2x dx is equal to f is a log 2x into integration of x dx minus integral of f dash, that is d by dx of log 2x into integration of x dx the whole dx. So we can write log 2x into integration of x is x square upon 2 minus integral of differentiation of log 2x is 1 upon 2x into 2 integration of x is x square upon 2 dx. So here we can write x square upon 2 log 2x minus 1 upon 2 times of integration of x dx, that is x square upon 2 log 2x minus 1 upon 2 integration of x is x square upon 2 plus c, or we can also write x square upon 2 log 2x minus x square upon 4 plus c is the answer. Integrate the function x square into log x. So we can write integral x square into log x dx. So here it's a product of two functions. First function is an algebraic function and the second one is a logarithmic function. And according to the rule of Eilert, first logarithmic function and then followed by algebraic function is the second one. So we can consider logarithmic is the first function and algebraic is the second function. And we know that integral of f into g, where f is the first function and g is the second function, f into integral g minus integration of f dash into integral of g. So we can write, so first function log x into integral of x square dx minus integration of f dash, that is differentiation of d by dx of x square into integration of, sorry, f is the log x, so differentiation of log x into integral of x square dx the whole dx, which is equal to log x into integration of x square is x power 3 upon 3 minus integral of differentiation of log x is 1 upon x into integration of x square is x power 3 upon 3 dx. So we can write x power 3 upon 3 log x minus here x 2 times, so x square upon, that is 1 upon 3 times of integration of x square is x power 3 upon 3 plus some constant. So we can write x power 3 upon 3 log x minus 1 upon 9 times of x power 3 plus c will be the answer. Integrate the function x into sine inverse x dx. So here the two functions, one is algebraic function and another one is inverse trigonometric function. And according to the rule I laid, I inverse function comes first and algebraic function comes second. So let us consider this is the first function and algebraic is the second function. And we know integration of f into g is equal to f integral g minus integral of f dash into integral of g, where f is the first function and g is the second function. So we can write here integral x into sine inverse of x dx is equal to sine inverse x into integration of x dx minus integral of differentiation of, that is d by dx of sine inverse x into integral of x dx whole dx, which is equal to sine inverse x into integration of x is x square upon 2 minus integral of differentiation of sine inverse x is 1 by root of 1 minus x square into integration of x is x square upon 2 dx. So we can write x square upon 2 sine inverse x minus 1 upon 2 times, or we can write plus integral minus x square upon root of 1 minus x square dx. Or this can also be written x square upon 2 sine inverse x plus 1 upon 2 times of integral adding and subtracting 1. So we can write x square upon 2 sine inverse of x plus 1 by 2 times integral of 1 minus x square upon root of 1 minus x square minus 1 upon root of 1 minus x square dx. So we can write x square upon 2 sine inverse x plus 1 upon 2 times of integral. Here root x upon root x can be taken as root of 1 minus x square dx, and again minus integral 1 by root of 1 minus x square dx. And we have integral root of a square minus x square dx is equal to x upon 2 root of a square minus x square plus a square upon 2 plus a square upon 2 into sine inverse of x upon a plus c, and also integral 1 upon root of 1 minus x square dx is equal to sine inverse x plus c. So let us apply these both. We can write x square upon 2 sine inverse of x plus 1 by 2 times of integration of root of 1 minus x square. We can write x upon 2 root of 1 minus x square plus 1 upon 2 sine inverse of x upon 1, and again minus integration of 1 upon root of 1 minus x square is sine inverse x plus c. So here is equal to x square upon here x square upon 2 sine inverse of x plus x upon 4 root of 1 minus x square plus 1 upon half minus half is minus half. So we can write minus 1 by 4 minus 1 upon 4 sine inverse of x plus c. Or we can also write 1 by 4 common, so we can write 2x square, or sin inverse x also we can take common. 2x square minus 1 plus x upon 4 root of 1 minus x square plus c is the answer. Integrate the function x into tan inverse x dx. So here two functions, one is algebraic function and another one is inverse trigonometric function. So according to the rule of highlight, so first function is inverse trigonometric function and then algebraic function is the second one. So here we can write inverse trigonometry tan inverse x is the first function and x is the second function. And we know that integral of f into g is equal to f into integral of g minus integration of f dash into integral of g. So where f is the first function and g is the second function. So we can write integral x into tan inverse x dx is equal to tan inverse x into integration of x dx minus integral of differentiation of the first function, that is tan inverse x, into integral of x dx and again whole dx. So which is equal to tan inverse x into integration of x is x square upon 2 minus integral of differentiation of tan inverse x is 1 upon 1 plus x square into integration of x is x square upon 2 dx, which is equal to x square upon 2 tan inverse of x minus 1 upon 2 times of, we can write 1 plus x is adding 1 and subtracting 1 divided by 1 plus x square dx, which is equal to x square upon 2 tan inverse of x minus 1 upon 2 times of integral 1 plus x square upon 1 plus x square is 1 minus, and again here 1 upon 1 plus x square dx, which is equal to x square upon 2 tan inverse of x minus 1 by 2 integration of 1 dx, and again here plus integral 1 upon 2 times of integration 1 upon 1 plus x square dx. So x square upon 2 tan inverse x minus 1 by 2 integration of 1 dx is x, and again plus 1 by 2 times, and we know that integration of 1 upon 1 plus x square dx is equal to tan inverse x plus c. So we can add 1 by 2 times tan inverse x plus c. So finally we can give the answer x square upon 2 tan inverse x minus x upon 2 plus 1 by 2 times of tan inverse x plus c is the answer. Integrate the function x into cos inverse x dx. So here two functions, one is algebraic function x and another one is inverse trigonometric function. As per the rule of highlight, first inverse trigonometric function and then algebraic function. So we can consider algebraic function is the second function and inverse trigonometric function is the first one. So this is the first function and this is the second function, and we note that integral f into g is equal to f into integration of g minus integral of f dash into integration of g. So which is equal to, we can write x into cos inverse x dx is equal to, so the first function is f is cos inverse x, so we can write cos inverse x into integration of x dx minus integral of differentiation of cos inverse x into integration of x dx and again the whole dx. So which is equal to cos inverse x into integration of x is x square upon 2 minus integral of differentiation of cos inverse x is minus 1 by root of 1 minus x square into integration of x is x square upon 2 the whole dx, which is equal to x square upon 2 cos inverse x minus or minus of minus plus integral x square upon root of 1 minus x square dx. And here we can write x square upon 2 cos inverse of x plus, or we can write minus of minus x square. So 1 adding and subtracting 1. So dx, which is equal to x square upon 2 cos inverse of x minus integral of 1 minus x square upon root of 1 minus x square dx, and again plus integral 1 upon root of 1 minus x square dx. And here 1 by 2 is there, so let me write 1 by 2. So we can write x square upon 2 cos inverse x minus 1 upon 2 integral, and since it is x upon root x is root x, so we can write root of 1 minus x square dx, and again plus 1 by 2 integral of 1 by root of 1 minus x square. And we know that integral 1 upon 1 by root of 1 minus x square is equal to sine inverse x plus c, or also 1 upon root of 1 minus x square is equal to minus cos inverse x plus c. So let us write in terms of minus cos inverse x. So we can write minus cos inverse x plus c, and next again integral root of a square minus x square dx is equal to x upon 2 root of a square minus x square plus a square upon 2 sine inverse of x upon a plus c. So we can just conclude x square upon 2 cos inverse x minus 1 by 2 times of x upon 2 root of 1 minus x square plus 1 upon 2 sine inverse of x upon 1, that is sine inverse x minus 1 by 2 cos inverse x plus constant c. So, and we know that sine inverse x plus cos inverse x is equal to pi by 2. So we can write x square upon 2 cos inverse x, and here again minus 1 by 2 cos inverse x, and minus 1 by 4 sine inverse x, we can write it as pi by 2 minus cos inverse x minus x upon 4 root of 1 minus x square plus some constant c. Or we can also write x square upon 2, or you can take cos inverse x common, cos inverse x taken common, so we can write x square upon 2 minus 1 upon 2, and again here plus 1 upon 4, and the remaining minus x upon 4 root of 1 minus x square minus pi by 8 minus pi by 8 plus constant c. So here we can write 4 is LCM, so 2x square, and here it comes minus of plus 1/4 is minus 1/4. So we can write 2x square minus 1 of cos inverse x, and again minus x upon 4 root of 1 minus x square, and here we can consider c minus pi by 8 is again a constant, so we can just use another constant, say c1. So we can consider the answer 2x square minus 1 of cos inverse x by 4 minus x upon 4 root of 1 minus x square plus c is the answer. Integrate the function sine inverse x whole square dx. So here it's a single function sin inverse x whole square. So let us consider 1 into sin inverse x whole square. So that one is an algebraic function and another one is a inverse trigonometric function. According to the rule of highlight, inverse trigonometric function will come the first function. So we can consider sin inverse x whole square as a first function and one is a second function. And we know integral f into g, where f is the first function and g is the second function. F into integral g minus integral of f dash into integral of g. So we can write 1 into, that is sin inverse x first function, into 1 dx is equal to sin inverse x whole square. Sin inverse x whole square into integration of 1 dx minus integral of differentiation of sin inverse of x whole square. So we can write d by dx of sin inverse x whole square into integral of 1 dx, again whole dx, which is equal to sin inverse x whole square into integration of 1 dx is x minus integral of differentiation of 2 sin inverse x whole square is 2 times of sin inverse x into differentiation of sin inverse x is 1 by root of 1 minus x square into again integration of 1 dx is x, the whole dx. So we can write x into sin inverse x whole square minus 2 times of x into sin inverse x upon root of 1 minus x square dx. So for this integral, let us substitute or put sin inverse x is equal to t, so that x is equal to sin t, and differentiating here 1 by root of 1 minus x square dx is equal to dt. So we can write here x into sin inverse x whole square minus 2 times of x is nothing but sin t into sin inverse x is nothing but t, and dx is nothing but 1 by root of 1 plus x square dx is dt. So it is nothing but integration of t into sin t. So x into sin inverse x whole square minus 2 times of again integration of sin t into t. So one is algebraic function and the sin t is a trigonometric function. So trigonometric function will come later. So this is the function, second function, and t is the first function. So we can write t into integral of sin t dt minus integral of differentiation of t is 1 into integration of sin t, the whole dt. So we can write x into sin inverse x whole square minus 2 times of t into integration of sin t is minus cos t minus integral of integration of sin t will be again minus cos t dt, which is equal to x into sin inverse x whole square minus 2 times of, or minus of minus, plus 2 times of, we can write plus 2 times t cos t, and again minus of minus plus here, and again minus 2 times of integration of cos is sin t plus c. So let us substitute back t is equal to, so x into sin inverse x whole square plus 2 into t is nothing but sin inverse x, and here we can write cos of sin inverse x minus 2 sin t is nothing but x plus c. And when sin inverse x is equal to t, then cos inverse x is equal to r. When sin inverse x is equal to t, then we can write x is equal to sin t, then cos t is equal to root of 1 minus x square. So t we can also write it as cos inverse root of 1 minus x square. So we can write x into sin inverse x whole square plus 2 times of sin inverse x is nothing but t, or sin inverse x into cos of sin inverse x, that is cos t, is equal to, we can substitute directly here, root of 1 minus x square minus 2x plus c. So x into sin inverse x whole square plus 2 times of root of 1 minus x square into sin inverse x minus 2x plus c will be the answer. Integrate the function x into cos inverse x upon root of 1 minus x square dx. So here let us go with substitution. Put cos inverse x is equal to t, so which implies cos t is equal to x, or differentiating minus 1 by root of 1 minus x square dx is equal to dt. So we can write the integral minus dt, here x is nothing but cos t and cos inverse x is nothing but t into dx upon root of 1 minus x square is minus dt. So integral minus t into cos t dt, and one is algebraic function and another one is trigonometric function. As per the rule I laid, algebraic function will come for the first and trigonometric will the second function. So let us use the rule fg, f into integral g minus integration of f in f dash into integral of g, so which is equal to negative of, so we can use t into integration of cos t will be sin t minus integration of differentiation of t is 1 into integration of cos t is again sin t dt. So we can write minus of t sin t minus of minus plus integration of sin t is minus cos t plus c. So we can write minus t sin t minus cos t plus c. Substituting back, t is equal to cos inverse x, and when cos t is equal to x, so we can write sin t is equal to root of 1 minus x square. So we can write minus cos inverse x into root of 1 minus x square, and again cos t is nothing but x plus c. So here minus cos, so minus of minus plus sin t integration is minus, so we can give the answer as root of 1 minus x square into cos inverse x negative, and again here minus x plus c is the answer. Integrate the function x into secant square x dx. So here x is algebraic function and secant square x is a trigonometric function. So as per the rule of Euclid, so first algebraic function and then trigonometric function. So we can consider first function is x and second function is secant square x. So we can write, and we have integral fg is equal to first function into second function is equal to f into integral of g minus integral of f dash into integral of g. So we can write x into secant square x dx is equal to x into integration of secant square x dx minus integration of differentiation of x into integration of secant square x and then whole dx. So which is equal to x into integration of secant square x is tan x minus integral of differentiation of x is 1 into integration of secant square x is tan x dx. So we can write x into tan x minus integration of tan x is log of cos x, or log mod of cos x we can write, plus c, or we can write log mod of secant x, sorry. So we know that integration tan x dx is equal to log mod of secant x plus c, or we can write minus log mod of cos x plus c. So let us write here minus. So minus of minus plus here, log mod of cos x plus c is the answer. Integrate the function tan inverse x dx. So here it is only single function. So let us consider 1 into tan inverse of x dx. So 1 is an algebraic function and tan inverse x is an inverse trigonometric function. So as per the rule of highlight, so we can go with first inverse trigonometric function and then algebraic expression is the second. So we can consider this is first function and say this is second function, and we have integral fg is equal to f into integral g minus integral of f dash into integral of g. So first function f is equal to tan inverse x, so we can write integral tan inverse x into 1 dx is equal to tan inverse x into integration of 1 dx minus integral of differentiation d by dx of tan inverse x into integral of 1 dx and again the whole dx. So we can write tan inverse x into integration of 1 dx is x minus integral of differentiation of tan inverse x is 1 upon 1 plus x square into integration of 1 dx is x whole dx. So which is equal to x tan inverse x minus integral of x upon 1 plus x square. So here let us substitute, put 1 plus x square is equal to t. So we have 2x dx is equal to dt, or x dx is equal to 1 upon 2 dt. So we can write x dx is 1 upon 2 dt divided by t. So we can write x tan inverse x minus 1 upon 2 integration of 1 upon t is log mod t plus c, or we can write x into tan inverse x minus 1 by 2. Our t value is 1 plus x square. So log mod of 1 plus x square plus c is the answer. Integrate the function x into log x whole square dx. So here x is an algebraic function and log x is a logarithmic function. So according to the rule of highlight, first logarithm will come. So let us consider this is the first function and then algebraic function. Let us take x is the algebraic function and we have integration of f into g, where f is the first function and g is the second function. So f into integral of g minus integral of f dash into integral of g. So let us write here integral x into, or we can write log x whole square into log x whole square into x dx is equal to, so we can write log x whole square into integration of x dx minus integral of f dash is differentiation of log x whole square is, let me write d by dx of log x whole square into integral of x dx and again whole dx. So which is equal to integration of x is x square upon 2 log x whole square minus integral of differentiation of 2 log x whole square is 2 into log x into differentiation of log x is 1 upon x into integration of x is x square by 2 dx, that is x square upon 2 log x whole square minus, here we can write integral of x into log x dx. So here this integral again by parts, x into log x. So x is an algebraic function and L is log is a logarithmic function. So we can consider this is a logarithm is the first function and algebra is the second function. And we can write x square upon 2 log x whole square minus, and here log x into integration of x is x square by 2 minus integral of differentiation of log x is 1 upon x into integration of x is x square upon 2 dx. So which is equal to x square upon 2 log x whole square is equal to log x whole square minus x square upon 2 into log x minus of minus plus, and here it is 1 upon 2 times integration of x is x square upon 2 again plus c. So we can give the answer as x square by 2 log x whole square minus x square upon 2 log x plus x square by 4 plus c is the answer. Integrate the function x square plus 1 into log x dx. So here x square plus 1 is an algebraic function and log x is a obviously logarithmic function, and according to the rule of Euclid logarithmic function will come first. So let us consider first function is log x and algebraic function will come second, and we have the first function into second function fg is equal to f into integral of g minus integral of f dash into integral of g. So we can write here integral log x into x square plus 1 dx is equal to log x into integration of x square plus 1 dx minus integral of d by dx of log x into integral of x square plus 1 dx and again whole dx. So which is equal to log x into integration of x square plus 1 is x power 3 by 3 plus x minus integral of differentiation of log x is 1 upon x into integral of x square plus 1 is x power 3 upon 3 plus x dx, or we can write x power 3 upon 3 plus x times of log x minus, and here we can take x common integral, so we will get x square upon 3 plus 1 dx. Now integrating we can write x power 3 upon 3 plus x times log x minus integration of x square is nothing but 1 upon 3 times x power 3 divided by 3 and again minus integration of 1 dx is x plus c. So that is x power 3 upon 3 plus x times of log x minus x power 3 upon 9 minus x plus c is the answer. Integrate the function e power x into sin x plus cos x dx, and we know that if f of x is equal to sin x and then f dash of x is equal to cos x, so we can write e power x into sin x is f of x and cos x is f dash of x dx, and we had a property e power x into f of x plus f dash of x dx is equal to e power x into f of x plus c is the answer. So from this property we can write e power x into f of x is sin x. So e power x into sin x plus c will be the answer. Integrate the function x into e power x upon 1 plus x whole square dx is equal to e power x into x upon 1 plus x whole square. So which can also be written e power x into adding and subtracting 1. So we can write integral e power x into 1 plus x upon 1 plus x whole square minus 1 upon 1 plus x whole square dx, which is equal to integral e power x into 1 upon 1 plus x minus 1 upon 1 plus x whole square dx. Let us consider or put 1 upon 1 plus x is equal to f of x, so that differentiating f dash of x is equal to minus 1 by 1 plus x whole square. So we can write e power x into 1 upon 1 plus x is f of x and minus 1 by 1 plus x square is f dash of x. And we have the property e power x into f of x plus f dash of x dx is equal to e power x into f of x plus c. So we can write e power x into f of x is 1 upon 1 plus x plus c. So the final answer is e power x upon 1 plus x plus c. Integrate the function e power x into 1 plus sin x upon 1 plus cos x dx. So here we can write sin x is equal to 2 sin x upon 2 cos x upon 2, and 1 plus cos x we can write 2 cos square x upon 2. So we may write the integral e power x into 1 plus 2 sin x upon 2 into cos x upon 2 divided by 2 cos square x upon 2 dx, or e power x into 1 upon 2 cos square x by 2 plus 2 sin x by 2 into cos x by 2 upon 2 cos square x by 2, that is 2 cos x upon 2 into cos x upon 2 dx, which is equal to e power x into 1 upon 2, 1 by cos square is secant square x by 2, and here we can write 2 and 2 gets cancelled, cos x by 2 cos x by 2, so it is tan x by 2. So we can write here plus tan x upon 2 dx, and we know that differentiation of tan x by 2 is equal to secant square x by 2 into 1 by 2, that is 1 by 2 half secant square x by 2 will be the differentiation of tan x by 2. So this can be written as integral e power x into tan x by 2 plus 1 by 2 secant square x by 2 dx. So that, so here f of x is tan x and f dash of x is equal to 1 upon 2 secant square x by 2. So by using the property integral e power x into f of x plus f dash of x dx is equal to e power x into f of x plus c. So we can give the answer here e power x into f of x, that is tan x by 2 plus c is the answer. Integrate the function e power x into 1 upon x minus 1 upon x square dx, which is equal to, so here very clearly we can say that e power x into, if f of x is equal to 1 upon x, then f dash of x is equal to minus 1 by x square. So here f of x is 1 upon x and minus 1 by is f dash of x, minus 1 by x square. And by using the property we can say integral e power x into f of x plus f dash of x dx is e power x into f of x plus c. So here f of x is 1 upon x, so we can give the answer e power x into f of x is 1 upon x plus c, or we can write e power x upon x plus c is the answer. Integrate the function x minus 3 times of e power x upon x minus 1 whole power 3 dx. So we can write here e power x times x minus 3, we can write x minus 1 minus 2 upon x minus 1 whole power 3 dx, or upon simplifying we can write e power x times x minus 1 minus 2 upon x minus 1 whole power 3 dx, or this can also be written x minus 1 upon x minus 1 whole power 3 minus 2 upon x minus 1 whole power 3 dx, that is e power x times 1 upon x minus 1 whole square minus 2 upon x minus 1 whole power 3 dx. And here if we can substitute, or if f of x is equal to, if f of x is equal to 1 upon x minus 1 whole square, then f dash of x is equal to, so we can write minus 2 into x minus 1 whole to the power of minus 2 minus 1, that is minus 3, that is minus 2 upon x minus 1 whole power 3. So here e power x into 1 upon x minus 1 whole square is f of x, and minus 2 upon x minus 1 whole cube will be f dash of x. So integration will be equal to e power x into f of x plus c. This is the basic property. So here we can write answer e power x into f of x is 1 by x minus 1 whole square plus c, or e power x upon x minus 1 whole square plus c is the answer. Integrate the function e power 2x into sin x dx. So here sin x is a trigonometric function and e power 2x is the exponential function, and according to the rule of Euler, first trigonometric function and then exponential function. So we can say the first function sin x can be taken as the first function f, and the second function e power 2x we can consider the second function. So we have integral f into g is equal to f into integration of g minus integration of differentiation of f into integral of g. So where f is the first function and g is the second function, so we can write, or let us consider I is equal to integral e power 2x into sin x dx, so which is equal to applying, so sin x into integration of e power 2x dx minus integral of differentiation of sin x is cos x into integral of e power 2x dx and again whole dx, which is equal to sin x into integration of e power 2x is e power 2x upon 2 minus integral of cos x into integration of e power 2x is e power 2x upon 2 dx, or we can write e power 2x upon 2 sin x minus 1 upon 2 times of integral e power 2x into cos x dx. Again it is in the form byproduct, by parts you can use it, and we can write e power 2x upon 2 sin x minus 1 by 2 times, here cos x is a trigonometric function and e power 2x is the exponential function. So we can say first trigonometric function, so cos x into integral of e power 2x dx minus integral of differentiation of cos x. Differentiation of cos x is minus sin x into integral of e power 2x dx and again whole dx. So we can write I is equal to e power 2x upon 2 sin x minus 1 by 2 into cos x into e power 2x integration is e power 2x upon 2 and minus of minus plus into again minus 1 by 2 integral of sin x into e power sin x into e power 2x upon 2 dx. So we can write this as I is equal to 1 upon 2 e power 2x sin x minus 1 by 4 e power 2x into cos x minus 1 by 4 times of integral of sin x into e power 2x is nothing but I. So we can write here y plus I by 4 is equal to taken 4 LCM. So we can write 2 times of e power 2x sin x minus e power 2x into cos x, or 5 times 5 by 4 is equal to e power 2x upon 4 taken common 2 sin x minus cos x, or we can cancel here I is equal to 1 upon 5 times of e power 2x into 2 sin x I is equal to e power 2x times 2 sin x minus cos x upon 5 plus integral constant c. Integrate the function sin inverse of 2x upon 1 plus x square dx. Let us solve this problem by substitution method. Put x is equal to tan theta, so that differentiating will have dx is equal to secant square theta d theta, and also sin inverse of 2 into x, that is 2 tan theta upon 1 plus tan square theta into dx is secant square theta d theta we can write, which is equal to sin inverse of, we know that 2 tan a upon 1 plus tan square is sin 2 theta into secant square theta d theta. Here we can write sin inverse of sin 2 theta is 2 theta into secant square theta d theta, and here theta is nothing but tan inverse of x. So let us use by parts. Here theta is like an algebraic function and secant square is a trigonometric function. So by using the rule of highlight, so algebraic function first and trigonometric is the second. So here it is the first function and secant square is the second function. So we can write 2 times integral theta into secant square theta d theta. By using the FG rule, we have f into integral of f into g is equal to f integral g minus integral of f dash into integral of g. So we can write 2 times of theta into integration of secant square is tan theta minus integration of differentiation of theta is 1, again integration of secant square theta is tan theta d theta, or is equal to 2 times of, or 2 times theta into tan theta minus 2 times of integration of tan theta is log mod of secant theta plus c, or 2 into theta is nothing but tan inverse x, and tan theta is equal to x minus 2 log mod of secant theta. So here when x is equal to tan theta, so let us consider tan theta is opposite by adjacent, so x upon 1. So we have here root of 1 plus x square. So secant theta is nothing but root of 1 minus 1 plus x square upon 1. Secant theta is hypotenuse by adjacent. So we can write root of 1 plus x square upon 1. So 2 log mod secant theta means root of 1 plus x square plus c. So finally we can give the answer 2x times of tan inverse x minus log, we can take this 2 as a power, root of 1 plus x square whole square plus c, or we can give the answer 2x tan inverse x minus log mod of 1 plus x square plus c is the answer. Choose the correct answer. Integral x square into e power x power 3 dx. So here let us substitute first. Put x power 3 is equal to t, so that differentiating 3x square dx is equal to dt, or we can write x square dx is equal to x square dx is equal to 1 upon 3 times of dt. So we have integral x square dx is dt 1 upon 3 into e to the power of t into dt, or 1 by 3 times of integration of e power t is e power t plus c. So we can add 1 by 3 e to the power of t is nothing but x power 3. So e to the power x power 3 plus c. So we can go with an option 1 by 3 times of e power x power 3 plus c, which is option A. Choose the correct answer. Integral e power x into secant x of 1 plus tan x dx, which is equal to e power x secant x plus secant x tan x. And we know that differentiation of secant x is secant x tan x. So if f of x is equal to secant x, then f dash of x is equal to secant x into tan x. So we can write integral e power x into f of x plus f dash of x dx. So which is equal to e power x into f of x plus c is the formula. So here we can write e power x into f of x is secant x. So e power x into secant x plus c is the answer, which is option B.